Welcome back, and we're returning to Chapter 5. In this instance, we're going to be looking at mode profiles, and they're described in both sections 5.7 and 5.9, covering a mode of SH, shunt, or OS on site. So we need to start by thinking about a movement authority. The movement authority enables the train to be moved, and is the extent of the movement that is allowed. So how does a mode profile work with a movement authority? Well, in the absence of a mode profile, the movement authority will enable the onboard to enter full supervision. It is the mode profile, which is included in the message where the movement authority is sent, that controls whether the train will change to a different mode for all or part of the movement authority. So the mode profile is allowing the trackside to instruct the onboard about a change to mode at a certain location, and the extent that that mode will apply for. So let's look at this based on a typical bit of railway. We have our reference beliefs group, the LRBG, and that is the reference for our movement authority. In this instance, we're looking at a level 2/3 movement authority, so it's packet 15, which would have been transmitted as part of message 3. The movement authority defines the extent of the movement, and normally it would be divided into a number of length sections. It doesn't have to use the first two sections, but it is normal to do so. Within the movement authority, an OS area may be defined, and that is contained in another packet, packet 80. Packet 80 allows more than one mode profile to be defined for any movement authority. However, in this instance, we're just looking at the one. Each mode profile can be for on-site, limited supervision, or shunting, but here we're going to look at OS. The start of the mode profile is defined by a reference distance D MA mode from the same LRBG, and the extent of the mode is defined as L MA mode, the length. When the driver is driving, they will not know that they are going to change to OS at a certain location, so they need to be given some warning. So the system allows for an acknowledgement window to be defined, and this is a distance L AC MA mode on approach to the start of the OS mode profile. So how's it all going to work, and how will the onboard respond? Well, the first thing is that effectively we would create a temporary end of authority at the start of the OS mode profile. That will be displayed on the DMI as a target and the distance to go, and beyond it, the movement authority will be hidden. The planning area will not contain information regarding it. As the train approaches, the onboard will be calculating a braking curve to achieve a stop at that temporary end of authority, exactly the same as if it was a normal end of authority. For each mode, there is the option to define the speed that applies whilst the train is in that mode. Normally that would be the national value. It could be the default value in the absence of national value, or in some circumstances it may be appropriate to define a mode within packet 80. VMA mode may use one of the reserve values or define a speed in multiples of 5 kilometers per hour, and that speed can be both higher or lower than the normal national value. The onboard calculates that speed going back to the start of the acknowledgement window, so that it creates a window of when OS will be offered to the driver. The driver needs to be within the distance defined LMA mode and below the speed VMA mode for on-site to be offered. Otherwise, they'll still be supervised towards the temporary EOA. So if you look at a speed profile of the train approaching this temporary EOA, once it reduces speed sufficiently to get in below the OS mode speed, and it has entered the acknowledgement window, then the driver will be offered OS. Because this is a restrictive change, the driver needs to acknowledge the transition. The icon will be displayed in yellow with a flashing yellow border, and there will be a warning tone to alert the driver. Once the driver is ready to accept OS, Then they will acknowledge it. Until they do so, the temporary EOA still applies and the train is supervised to stop at it. Once OS is accepted by the driver, the MA mode speed becomes effective immediately and the train changes to on-site, as shown by the mode icon. And it will remain in OS until the estimated front of the train has left the OS mode area. Now, different types of trains will experience different calculations, and that will affect the drivability. Confidence intervals may be increased or reduced. The braking curves may be more conservative or more aggressive, and that can make it hard for the driver. If the acknowledgement window is very short, then in order to reach it, the train may need to be supervised a long way down the braking curve, particularly if the braking curve is very conservative and there's a large confidence interval. That may make it hard to be drivable for that last part. So what we can do is use the whole of the movement authority to define the supervised location. So packet 80 includes a variable QMA mode, and this determines whether the temporary EOA is used as a supervised location or the extent of the actual movement authority itself. If the temporary EOA is used as a supervised location, we can expect that the calculated brake curve will result in the train being supervised to a stand on approach to that temporary EOA, typically the confidence distance. And that curve of supervision will be based on the emergency brake curves, which can be more conservative. That means that OS will be entered earlier than if we allow the whole of the movement authority to be used for the supervised location. In this case, we now use the estimated train position and we use the service brake curve, which can be more generous, and that will be targeted on the temporary EOA. So this is a number of things that can be configured within the mode profile. In addition to the distance and the length of the mode, the acknowledgement window and its speed, we can also control how the brake curve to the temporary EOA will be managed.